So yesterday we talked about triangles and putting two identical triangles together. So on the first problem it says that here is triangle M. Han made a copy of triangle M and composed three different parallelograms using the original M and the copy as shown here. So you have M and the copy, M and the copy, M and the copy. For each parallelogram Han composed, identify a base and a corresponding height and write the measurements on the drawing. So for this one, I'm going to use the base of 1, 2, 3, 4, 5, 6, a base of 6, and a height of 1, 2, 3, 4. So the height here is 4, and the base is 6. Over here, I'm going to use a base of 4, 1, 2, 3, 4, and a height of 1, 2, 3, 4, 5, 6. Because remember, for parallelograms, we can use any side of the parallelogram as our base, just as long as the height that we use is perpendicular to that, meaning that it forms a right angle. Over here, I'm going to use a base of 6 and a height of 1, 2, 3, 4. So I identified the bases and heights for this. The second part of this question asks to find the area of the parallelogram. So remember that our area formula is base times height, which equals area. And then I'm going to plug in 6 times 4 equals 24, or I could write 4 times 6, depending on the base that I used, and I have to use square units for both of my pieces, because when we find area, that's having the unit is an important quality. So then we flipped the page over and we talked about how to find the area of, like it asked us to find the area of at least two of these triangles. So on these questions, students were allowed to pick two and solve, but if they did more, that's always better. So on this one here, this has a base of 8 and a height of 2. Remember to find the area of a triangle. Area equals base times height divided by 2. So I'm going to plug in 8 times 2 divided by 2, and that equals 8 square units. So this one is 8 square units. What you need to understand from this model is that from this diagram, is that you can also, show me this to help you out solve that. Remember, because it takes two identical triangles to make a parallelogram. So the first one should be 8. Over here on B, what I'm going to do is I can also find the base, 1, 2, 3, 4, 5, 6, 7. I have a base of 7, and I have a height of 3, because remember the height has to go at a right angle, and it has to go from from the base to the vertex, so that's 3. So I have A equals B times H divided by 2, so then I have 7 times 3 divided by 2, that gives me 21 over 2, and that simplifies to 10 and a half. For this problem too, you can also show a rectangle if you wanted to so that you could find the missing pieces here. So in this one, you don't have two triangles that look identical, but if you merged this smaller triangle with this other triangle over here, those would be identical, right? Because if you notice that when I drew this line here, that's a perfect little rectangle, and that's a perfect little rectangle as well. So if you would have merged these two triangles together, it would make this shape that you see here, because you flip that, and then you flip that, and then it's perfect. It's a perfect match. So that you have an identical triangle there and an identical triangle there as well. On C, what we're going to do is we can still find the base, right? 1, 2, 3, 4, 5. I have a base of 5. And for height here, notice that it's not perfect, but I can write here 1, 2, 3, 4. And remember, I have base times height divided by 2. So I have 5 times 4 divided by 2. That's 20 divided by 2, which is 10. For this triangle, notice that it's on a curve, so if you actually drew something, it would need to look something like this, because that's going to be the perfect, an identical copy. So that's a parallelogram, and we just remember slicing it in half because this is identical to this. On D over here, we're going to find the, I'm actually going to draw a rectangle because it's easier for me to see it this way than it is to see it naturally. I can find the base, 1, 2, 3, 4, but the height, notice that if I draw here, it doesn't go to the vertex perfectly, so that's why I drew a rectangle to help me sort that out. So then I have 1, 2, 3, 4, 5, 6. Remember, I have base times height divided by 2. I have 6 times 4, and then cut in half, so that's 24 divided by 2, which equals 12. Because remember, again, this smaller triangle, right, if I take this smaller triangle and merge it with this triangle together, it's going to be able to completely cover this and be identical to that, right? So those are the second part of that. On the last part of this, we did kind of a discovery activity where I gave, where students had the option of choosing parallelograms. So on the first one here, it says glue or tape one copy of your parallelogram here and find its area. So this is what the parallelogram that I had looked like. So I'm going to tape it down, and then it's asking me to find its area. Notice that you'll see all these different numbers on this parallelogram, but we're just going to find its area. Remember, to find its area, we have to do base times height. So for this problem, I'm going to write base times height equals area. My base of this, notice that my base is 10, so I'm going to put 10. And my height goes from 1 perpendicular, right, to the top. That's 8. 10 times 8 is going to give me 80 centimeters squared, right? So that's the first problem, is just taking the parallelogram and finding its area. The second part of this question asks us to decompose the second copy of our parallelogram by cutting along the dotted lines. So notice that I have my parallelogram here, and what I'm going to do is I'm going to cut on those dotted lines like it tells me to. So I'm going to cut right along those dotted lines just like that. So I have a triangle here. Remember that there's still dotted line there, so I need to cut there as well. And then it says take only the small triangle and trapezoid. Notice I have a small triangle, a large triangle, and a trapezoid. It says take the trapezoid and the small triangle. I'm going to take this away because I don't need this, and rearrange these two pieces into a different parallelogram. So I want to arrange this into a different parallelogram. So what I'm going to do is I'm going to do something like, right, this, and I'm going to tape this down. So there's my parallelogram. Now I'm going to tape this down, because that's what it says, glue your new parallelogram down or tape it. So I'm taping it. Right? And then it said, so that's that part. And then this question says, find the area of the new parallelogram that I just made, and showed my reasoning. So remember, I have base times height equals area. The base of this is 10. The height of this is 4. 10 times 4 is 40 centimeters squared. Okay? So the next question asks us, what do I notice about the relationship between the area of this new parallelogram and the original one? So comparing this area to the one that I had on this page, right? This page, the area was 80, and on this page, the area is 40. So what I notice about that is that the area of my new parallelogram is half of the area of the original one. That's what I notice about their areas, is that this up here is half of the one I started with. And then the question 5 asks us, how do you think the area of this large triangle, so this is what I have left, compares to that of the new parallelogram? Is it larger, the same, or smaller? Why is that? So for this, right, if I know that this is 40 and that is half of what I started with, remember that I didn't do anything to the shape. I didn't cut any of the shape out. so if I put all this back together, it's asking us what should, in theory, this and this be. So if this right here is 40, then where did the other 40 go? The other 40 had to go here in this triangle, because if I put them together, that's going to equal the 80 that I started out with. So the area, right down here, we should say the area of the large triangle should be the same as the area of the new parallelogram. Because that's the theory, right? This should be the same. So that's that question. And then what I'm going to do is I'm going to flip over, and that's the last question of this, says glue or tape the remaining large triangle below. Use any part of the work above to help you find its area. So I'm going to tape this down, and I'm going to find its area, right? So the area of this, remember, area of a triangle, A equals base times height divided by 2. Plug in what I know. I know 10 times 8, and then remember to divide that by 2. So I do 10 times 8, which is 80, divided by 2, which equals 40 centimeters squared. Okay, so that gave me the same area as the new parallelogram. So in theory and in practice, it works out. Down here, we talked about how to decompose this triangle to make it into a rectangle. So the easiest way to do that is we're going to cut this top part off so that we have a trapezoid on the bottom and a triangle on top. And what I'm going to do with this is I'm going to move this piece down here, and it should look something like this when I move it. Now that's not going to be perfect, but you can get the idea there. So I moved this piece, and the arrow indicates that that's where I'm moving it. Now what I need to do is I need to create a straight edge right here. And then this missing piece now is going to go at that angle that I just created at the top. So it will fit like something like this. Because ideally, right, where I cut, this triangle and this triangle should match almost perfectly to make this into that rectangle that we want.